I always forget. Thank you.
Yeah, thank you.
Okay. Yeah, so I'm gonna just quickly explain this again because we didn't record the first part of the tutorial. So in the empty screen, you will have this three main dividers, and then one is your viewport, and then this is your properties, and then this is your tree for your coding. The Houdini is a visual scripting program, and then it's really good at handling 3D geometry. And then usually you start with the geometry node. How you make this is that you right click and then the type whatever the function that you want to find. And then once you click this, you can place it in your screen here. And once you made that, you can double click to get in here. And this is to define the hierarchy between the something that is on top and then there's something that's going to make this geometry. And we're going to name this voxel. Once we're in here, we're going to make a grid. The reason why we're making a grid is that we have these images, and then these are divided by like 1024, for instance, 1024. Then it means that from here to there, there's a 124 pixels, and same for the y-axis. If that's the case, we want to make a grid system that is a close replication of this like a pixel system, and then we want to use the grid to capture the information that is embedded in the image to use on various calculations to iterate the 3D from the 2D. Okay, so depends on your power of your computer. You might want a smaller or bigger grid system. I would recommend using, let's say, 128 by 128 to begin with, and then if your computer can handle it, you can increase it to 256 and then 512 and so on. So for my computer, I know that my computer can handle 256. So I'm going to increase my the size to be a little bit bigger than the 128. But for your purposes, you can pick whatever number you want, gauging your computer's ability to calculate these complex geometries. And we're going to name this 256 by 256 to indicate this is 256 and by 256 grid. But if you want, you can add another grid. Hello, Holly. Grid. And we're going to make it maybe we want to use a little bit more. And actually, I'm going to make this size 256. But still, the subdivision of your box is going to be the same as the other one. But then you can see that now on the 512 by 512 rows and columns have a larger, or not larger, but the finer grid system that's going to be more like a bucket that will capture all each individual pixels inside. Okay, and then I'm going to make this 512 by 512. Of course, you can have more, depends on your computer power. I just don't want to crash my computer while I'm doing Zoom, so I'm going to use a little bit of a small number. And then we want to put the subnetwork. Subnetwork is acting as some sort of a container that's it literally looks like a container here, right? Container to includes these contents, and you can connect these different nodes to different branches, and then once you go in there, you have subnet input 2, subnet input 1. Subnet input 1 is grid 256 by 256. And then the grid 512 by 512 is on the subnetwork input 2. So for this one, we're going to call this voxelizer. It's because it's going to make a voxel. Holly, what's your experience in the experience level in the Houdini? Holly?
I used to do some animation like breaking board and the pixel about the wave function. And in the side FX lab.
Yeah. Okay, so you have experience. So
yeah.
You don't have any. So I'm going to just show you what I did so far. It's very basic. We made the geometry.
Yeah.
Yeah, and inside of the geometry, we just made the 2 different grid system, and then we connected to the subnetwork. That's it. So it's not that much. So you can follow. I'll give you like a few seconds to just follow this far, and then I would recommend you follow me through throughout this process, because it's really easy to miss very miscellaneous thing while I'm progressing through the tutorial. So yeah, open your Houdini and then catch up this far.
Okay, thank you.
Okay, so everyone here? Good?
Yes.
Okay. And this output, we don't need it right now. So I mean, we can edit later. So I'm going to just delete it for now. But instead of that, we're going to put null. Null is just like empty bucket that can contain like almost anything in the Houdini. So once you connect this null to the your subnetwork, you can have these this as a representation of what you have already done so far. Okay, so we're here on the subnetwork, the input 1, but just to test this things out, we're going to connect this to 512 too, and in here I'm going to name this in geometry, and the next step is going to be bringing our the texture, which is image, and it's called the attribute from map. Attribute from map. Okay. So I'm on the attribute from the map, and I'm going to connect this. And once you have this attribute from map, you can see that now the window is active with the attribute from map. What's important here is this texture map node. Once you click this, you can load the images that you would like to put into your Houdini system. So for me, I'm going to use maybe a little bit of a small geometry that's more familiar to our eyes. I'm going to go to this one. This doesn't give me preview, so I'm going to open it from here. So I have like all these images. I'm going to select what I think that could be interesting and also demonstrative of what we can do with the Houdini script. What should I pick? Yeah, I'm going to pick this one maybe. I want to have something that has more of a modular texture. Yeah, let's do this one. Okay, that's east 242. 242. Where's 242? Well, okay, I accepted it. And another the function that you want to know is that this node. So when you click this blue eye thing, you can toggle your viewport mode. So if you click this one, now you see that our texture has been brought up to the Houdini, right? So you can always change back to your a step back or step the next step, and then see what has been updated from that specific node, which is quite convenient. And then these are something that we're not going to use today. But then when you say bypass, basically bypass will not run this specific node, and then it will just skip it. For our purpose, we don't really need it. And you can also lock this. If you don't want this to be changed by any accident, you can lock it. But you know, for today's tutorial, it's not going to be that complex, so we don't really need it. So as you can see, this one actually, because Houdini has a different coordinate system, so we're this image is rotated 90 degrees. How can you fix this? You can, let me close this out first. And what you can do is that you can basically change the image setting here, not the color setting, not the filter setting, but the image setting. When you go to image setting, you can rotate this by 90 degrees, maybe negative 90 degrees. I think that's actually the correct. Should I do this one? This looks cooler actually. And invert V, yeah. And after that, when you click the invert V, it will put your image in the correct manner. When I show you this image, this is the original image, right? This is the original image, and if it's in original state, it's like this, right? But if you do rotation and then invert V, this is now the correct representation of what the actual photo is. If you care about that, you should use this. And yeah, so we have successfully imported our texture. And now we're going to do the next step, which is going to be a scale manipulation. How are you going to change the scale? It's very simple. Just transform. Just add the transform node here. And whenever you have your extra node here, you need to connect it to the one before. Okay, and then we are going to change this the scale of this image to 0.25, 0.5, 0.5, so that it's more manageable size. Of course, you can change this from the beginning, but I'm just trying to explain to you guys what could be done with the different functions. So this whole code could be actually much shorter. In fact, actually, you can change the scale from your attribute map, right? It can be smaller or bigger. But anyway, we're now in the transform, and I'm going to actually name this extra, and then I'm going to call this scale. So we're at the scale manipulation, and we can also now connect next node. How can you make this a two-dimensional, very flat information to the 3D? What's your best guess? We know that we can use all this pixel informations. The easiest way to make the 2D to 3D is using a displacement. For those of you who have been worked in the architectural visualization or any sort of like a texture mapping work, you probably already know that there is a node called the displacement in your material. And then what that node actually does is that it's trying to replicate or simulate the depth of your object from a photo to the 3D 3D geometry. So, for instance, if you have a brick texture that looks like this, in real life, there's a mortar here. There's a mortar here, and then brick has a lot of indentations like this. How can you replicate that? Of course, image contains certain information, but then when you use a displacement, if I draw this in Exxon again, it will actually try to replicate the bumpiness of the brick, and then also the mortar being negative volume, then the positive volume. So it will try to simulate this based on the image analysis that your material node is doing. So this is what we're trying to do. Of course, with the regular displacement map, you wouldn't have that drastic effect because it's not designed to do this drastic three-dimensional tessellation. So there are multiple, let's say, amplification method that we're going to use today to really intensify that effect. So on the next node, we're going to call attribute BOP. This is a Houdini specific node that's letting you harvest information from the geometry global and then spit out the process geometry after it is processed. There are multiple values here, but then the two values that you need here is the P, which is the global, the variable that is a general kind of like information from your geometry, and then the CD is your RGB value. Okay, so for you only really need these two factors, and then the to use this CD, the color information. This is when you hover your mouse around here, you can see that it's now in vector. Why is the color information vector? Because the color information in the computer language is stored in the RGB, right? RGB, and it has a number, a range from the 0 to 255. So that means that you're actually in the three-dimensional array. This is R, this is B, this is G, and then you have a maximum cap to 55. Same for the R and the G and so your RGB information stays in this like a cube that is 255 and 255, and also this is 255, and then your vector the color value exists as a vector from as a point from origin to a certain point. Let's say you have a value of a 128, 128, 0. That's your, let's say, color value for specific the pixel. Then you will be your point is going to be here, right? So instead of us saving all these three numbers, computer is trying to save the vector that is from the 0 point to the this point. So what's difference between the vector to the numerical information? Vector has a direction, so that it suggests certain dimensionality. When you have three numbers contributing to the vector, this numerical information is actually transformed into directional information. For computer, sometimes it's faster to use the vector, so they store the color value as a vector. So but then to calculate things back, you need to unpack this again to numerical information, right? How do you do that? It's a mathematical process, but then you don't actually have to calculate this in Houdini. It will do it for you by using vector to float. If you remember the last 2 days workshop, you understand the difference between the vector and float probably by now. There's integer, there's a float, and there's a vector, and there's a string. Integer is a 0, 1, 2, 3, 4. Float is something that you can it's something including all the integer, but at the same time there are values between 0 and 1, right? 0.1, 0.2, 0.3, or 0.001. all this in between values between the integers are included in the float. And then vector is the direction. And then the string is a text information. Okay, so this is a kind of unique noun. And then the float is a very flexible number, and the integer is a very even number, and the vector is a direction. That's very diagrammatic way of explaining the float, vector, float, integer, and string. So now we're using this vector to float function. We connect CD to CD here to vector, because when you hover it here, it tells you CD is vector. So we're connecting vector to vector node, just like a grasshopper. And then now when you hover your mouse here, it is now float, right? Over here, instead of having this output right here, we're going to call displacement along normal. Displacement along normal, what does that mean? You have a plane like this, and then the normal to this plane is actually this way, to the z direction. If this is x, if this is y, this is z information. Okay. How do you calculate that? You are basically doing cross product of these two vectors, but we don't need to know this to this calculation, because Houdini is very kind to us and then doing this calculation for us. So from this vector, we're going to connect this the first node to amount, because we want to know the amount of a displacement that is to the normal of the surface. So if this is our surface, we want to know the normal. Normal is already defined by the displacement by normal to the normal direction. But then how much are we going to change this, right? That we don't know. If I draw this in, let's say, section, it will look like this, right? How do they know it? The simple explanation is that you have a brighter color, brighter color, brighter color, and then it seems like this is very shadowed area, this is very shadowed area, and then you have these millions. There's a certainly differentiation between the depths from our perception. How computer understand it is by the color differentiation between the one pixel to another pixel. So it would catch this smaller millions as a very tiny thing right here. And then for this kind of a more articulated piece, it might not capture the correct geometry because this is already in a darker area. So it might register the information in the way that's more general. Like for instance, it would look very blobby thing that looks like this. But we'll see what happens. Okay, so we now have connected the color value to the displacement, but our main thing is not connected. Here's a P, there's a P. You connect these main two values. Then now we're on the displacement, and we simply just connect the displacement P to P, and then displaced normal to normal. Then you will have some output at the end. So now I'm going to turn this on. This is very, very tiny amount, but then now you see the little bit of a tessellation here, right? And then but then this amount might not be enough for us. So we have to use a scalar value right here. Maybe 15 is too much, maybe not. you just need to test this out. You see like how this area, as I was telling you, is very grayed out, so it doesn't really catch it very accurately. But then when there is a great contrast between the one thing to another, it catches the variation quite well. And of course, this condenser, air conditioner condenser, is white, so it's captured quite well. And there could be another method. You can directly change your scale for the displacement, but then there is also another way, which is by introducing the multiplier. Multiplier is literally a cross product between the float, which is a number here, and then you multiply that by a certain number. You connect this float number to the your input here, and then you only need a certain constant. You see this constant here. Right now your constant is 0, so it actually make it flat. But then you can change this to 2, which will amplify your overall height of the tessellation, whereas when you do the scalar on the displacement, it will intensify the displacement power. So it's slightly different. I'm going to have it a little bit exaggerated like this for now, and then exit this attribute VOP, and we're going to name this displacement. Okay, everyone follow here? Good.
Yes, I'm mainly watching instead of doing. I think I can review the recording and actually do all of this.
Okay, no problem. Yeah. And we're going to add another subnetwork because we finished kind of prepping our 2D image to be the second 3D objects, right? So we're going to have another, let's say, a function defined here. It's called, you can add many, you can embed many functions within a function. So in here, what we're going to do is we're going to prepare these the geometry, I mean not geometry, this 2D image to be 3D ready. It's not ready yet because this is just a 2D image, and then it's just a stretched out 2D information, right? So, and it's quite spiky, and we don't want this much spike in our geometry. So we want to make it a little bit normal. So that's what we're going to do right now. So in the subnet, we're going to connect the null first. Null connected. And then we're going to call this zero. It's just a good practice to have this in the beginning, so that you will see what's the original state of your imported geometry. Okay, and we're going to create another transform node. Transform, and this transform node, the reason why I made it is that we want to, this is a perfectly square image, But then what if it's now perfectly square image that is not centered on the 0? So we want to make sure that our image is on the center, and then the within the frame that we're going to use for the voxelization. So I'm going to make this one called center geo, because we're going to center the geometry, and then we'll connect it here. And then how do you center this? This in the translate tab. The one thing that's pretty interesting about the Houdini is that you can actually write a code in this tab. So that's what we're going to do. When you do minus and the $sign CX, then it means that it's going to be centered on the your x-axis, and you can do the same on the y and z, and your image is a center. Okay, and just to make sure that this works, we can attach a switch. Switch is an if you use a grasshopper, you can have a switch, a toggle switch that is on and off. It's basically the same thing. When you click this one, there is a select input. When it's 0, it's on, and when it's 0, it's off, and then when it's 1, it's on. So we are turning this on, and then we're going to call this switch. Okay, so this is a switch that we made, and then what's the next one that's important? It's the defining a floor of this geometry. So to do this, we're going to create another transform. And we're going to call this defining floor, so we're going to call it floor. And we're going to connect it here, and in this case, we're only interested in this value. In Houdini, this is defining the floor, the coordinate that's defining the floor. It's a little bit different from the Rhino environment. It's a very Houdini specific kind of a way of doing the geometry. I don't know why they did it this way, but this is the how you define the floor. And this is now just a numeric information, but then you can, as you did in the center geo, you can add some very simple coding inside of here, which is going to be minus bounding box. BB box is short for the bounding box, okay? And then we're going to call it switch center geo, the one that we named right here, right? And then within that center geo, we're going to define the dy min. dy min is the limiting or the finding the lowest spot of the y-axis. Y is in Houdini the height. So let's say this is x and this is z, and then the normal is actually the y. That's why we're changing the y value. Okay, and that's about it. No, we actually have another step. We define the floor, and just to have a consistency, I'm going to add another switch here. Is that just looks better. And now you know what's happening. Something went wrong. Switch one. What's wrong? Unable to evaluate expression. Bracing her. Huh. Did I make an error? Maybe I misspelled something. Oh, I didn't close this. Yay. So this is string, right? This is a directory, so this is a string. So whenever you use a string, you need to close out after you're done with the string, so that the computer understands this is a text information that's been kind of captured by this quotation mark, so that it doesn't confuse with the other stuff. For instance, this is variable, and then you don't want to include the variable inside of the quotation mark, so that the Houdini will think that this is a part of the directory. In fact, it is not, and it is an independent variable. And next step is that we're going to literally make a box, which is Extrude Volume. Once you connect this, this requires some like fine tuning. When you just do this, you see that it's not having the sidewalls or nothing. It's just this is just this floating thing. But once you add this node, it will try to extrude all the way down, right? But is it desirable to capture this information as well? Maybe not. So you can choose to capture whatever height that you want to capture. If you want to only capture this part, that's fine. If you want to only capture that at that level, that's fine. That's your decision. So I'm going to use this one, and maybe instead of giving a depth of a -1, I'm going to give it a little bit of a height. This means that it's going to ignore everything that's under this box, and it's going to capture only the thing that's above. Okay, and for the base padding, I'll give 1 base lift. Maybe I don't need this. Yeah. For the depth, we can maybe give it a little bit more. 1, 2, 5, 6, maybe 6. I want to capture this window, so I have to make sure that that is included. Well, yeah, let's just do 0.5. And at the end, we're going to add the null again. And then call it. So this indicates what's the starting point for the this geometry procedural. So that's called the NGO, and after all this process, now it's going out. So it indicates it. So now we have that, and then we call this node pre-voxelized. Okay. And once we're here, now we have almost like 3D looking thing, but then it's not voxelized yet. So the next process is going to be the voxelizer, because this was pre-voxelized, right? And to do that, we're going to add another subnetwork. And I'm going to connect it here. And as usual, I'm going to just delete this. And we're going to add and then call this, right? And there is this function that we want to use, actually a very powerful tool, point from volume. What this function does is that as this diagram kind of suggests, if you have a volume, it will try to harvest the highest point of each individual, let's say, triangular mesh, and then it will collect points from that. So when I select this one as a view, you see that now it's reading all these geometries and then trying to collect all the possible points within it, right? But for our purpose, you can have a point separation of 0.1, but this is very, very, very heavy. So we're going to just put it 0.5 or even just 1. Then you will see much less density of points. But this, you can change it later on once you set it up, okay? And you can also change these this from grid to the tetrahedral to have different types of aesthetical effect. But for now, we're just going to keep it grid. And there are like different kind of the harvesting method, for instance, like dense grid and sparse volume, and that you don't have to change. And for now, we're going to just leave it here, and I'm going to go to the next step, and then we'll come back to it later, okay? So to voxelize, what do you need? You need voxel, right? And what is voxel? It's literally a box. So add the box as a geometry. This is box for voxel. And what we need here is just connect these. I mean, when you just make it visible like that, it's just a small box, right? What happens if you connect it to all the points that's inside of here? Let's see what happens. How to do that? There is a node called the copy to points. Look at that. That's now all corresponding to the points that we collected from the image, and then we're laying out each individual points inside of this point cloud. And you can play with this. You can change the scale to have different types of effect. You can have it even bigger to create some overlap. for now, I'm going to leave it at 1, and I'm going to play with this node right now. So things that you can change. You can change your ISO value, which make a decision, which then makes the decision of how much you're going to harvest from your image information. Larger the number, is going to be more generous about picking a point to generate the points, right? So you can see in real time how the code is making a decision to create certain things or not creating certain things, depending on the its height information, based on its height information. I just need to find a happy place that I'm okay with. I think that this right here, I think I like this, so I'm going to keep this. But there are many other things that you can do. For instance, if you want to think that this is the let's say a brick, then you can have a brick kind of aesthetic, just like that. Right? It kind of looks like a brick. You can make it thinner to create this kind of a platform. When you can imagine a version of your architecture that your whole the facade has this kind of permeable louver condition that's creating this interesting the stepping. I think that's pretty cool. Or you can even express this element in a vertical way, which is going to be not this one. I'll actually make this one, but this one. What if you so if you do this, now this kind of a like vertical element, if you want to express your architecture as an vertical tessellated facade, this is also one way to do it. And alternatively, you can even change the box to something else. In the create node, there's a sphere, there's a tube, there's a torus, there is a grid. There are a bunch of different types of geometry. Let's test out the sphere first. Sphere. We have now sphere. And then what happens if you bring this sphere? Now we have this blobby facade. And you can, for instance, increase the point separation and then change the radius of it. Then it will actually read much more as a collection of the points rather than the voxel. Like that. Right? And there are actually another step that I want to add to this, which is correlating the size of the these boxes to the points point separation, which is this one. Okay, so I'm going to write another node, transform, and then I'm going to stick it between here, and then I'm going to call this size match, or more of a scale match. And what we need here is that because we're trying to match the scale of this box to the point separation that's happening in the point from volume node. So what we need is write something on this side, okay? And then the linking this to the parameter is called the channeling. So for channeling, we're going to use this short syntax ch, and then we can call out the node information, which is in this case points from volume 1, which is right here, points from volume 1, right? And we shouldn't make the same mistake twice, and we need to close this, but we don't want to use this whole thing. We only need the scale from this point from volume. This point separation value, that's what we need. So we're going to call out that specific part, which is the particle separation. This particle sep is actually the one that's indicating this point separation. Now you see the difference, right? It wasn't corresponding to the point separation size, the voxel, but now it's corresponding to the size of the point separation. So whenever you change this, the point separation, your box will scale together. All right, you see it? And we're going to call this null, make a null, and then the null is basically a break in the Houdini, and we're going to say mid process, because this is we already finished all the processing, and then we now need to convert these geometry into the something that we can export. Now these are all separated, and then looks very heavy and so on. And also, whenever you don't want to use this scale mesh function, you can just bypass this. So that's an option. One is fine. And to do that, we are going to use this function called convert VDB. Convert VDB, right? And then we're going to connect it right here. And once you process it through this one, your geometry gets much lighter and all together rather than all broken up and then very heavy. And another step we're going to do is beat the VDB from polygons. Once you do this, this is a little bit heavy. Now you see that it's trying to converge all this volume into one thing if possible. So there are the things that were separated before, now it's converged into one polygon surface, right? And from once you made that as the polygon, there are some other options that you can try. 3dB res, 3dB resample. This resample, what this does is that it creates an it's sampling whatever the information here to be what happened. Oh yeah. You're just resampling, so it's even further reduced from the what we've seen before, right? You see that this is much now like low res. So when you're dealing with the high high mesh condition, you want to use the BTB resample. And another process that we can do is that if you don't like these like voxely aesthetic, you can make it smooth. Sometimes you need to wait for a second. Voxel release. Maybe it's not shown very well because it's not in the scale. Okay, you see like these are now like all the edges are not filleted, and then it has this more or less like a blobby aesthetic. You can change the radius of this 2, 3, 4. As you increase that number, it becomes more like filleted, right? And in terms of it, when you increase the iteration, it just becomes more like more smooth or accurate, more accurate in terms of the this fillet simulation. So this is iteration 1, this is iteration I mean 0 and this 1, and this is iteration 2, 3. Yeah, doesn't really change that much because we don't have that much of a space to fill it. But once you increase your point separation value, let's say you want it 2, you now have this more of a general kind of a tiled condition. Then this iteration process, you would see the differentiation a little bit more. You see like this line is getting disappeared little by little bit by little bit as you increase the iteration. But the most drastic change is from, of course, 0 to 1. Okay, and I'm just going to come back to this one or just this one again, and I'm going to show you a little bit more about what kind of other things that you can do. You can set up your minimum ISO value just to have a, let's say, buffer value in the end. Jitter and jitter scale, this is introducing a little bit of chaos into your particles. So you can, if you know how to animate in Houdini, as Holly mentioned before, you can actually animate these activation of your facade with the jitter. And the jitter speed, it doesn't change that much. Jitter speed, it doesn't really change that much because we already have too many components. But we can do also a scale attribute, which will overscale your objects or make your objects smaller than what it is. And of course, you can make this giant scale more chunky aesthetic, more like brutalist aesthetic, if you like. And also you can increase the density to make these more tactile. Of course, if you add this many, the density, this will be super, super, super heavy. So unless you have a very, very good computer, I wouldn't recommend using this. I mean, and it's this much of a density. But if you really want to try, you should, I think, try and play with this. And there is also a relaxation iteration, which doesn't do much right now because we don't have a density change. But when you have a density increased, the relaxation iteration is giving different types of compacting forces to your geometry. So I'm going to just turn it on, turn it off for now, and maybe maybe just a little bit. And you can oversample if your grid side is I forgot what's the one way, if it's one way or another way. But you know, the essentially what it does is if you have a grid condition, let's say you only have a one voxel in your grid. Basically, oversampling means that you're going to subdivide this into 4, and then you're going to try to sample your pixels more than how it is, more than what it is. So you will basically have a better resolution. Yeah, so these are the things that you can change in your setting, along with this connecting it to this sphere instead. I mean, when you look at this, this is looking much like atom structure that is like in a complex situation. But if you increase the jitter scale, of course, this will get much more blobby. For architectural application, I'm not sure if this is helpful, but then for any sort of like a biological form, I think this will create very interesting result. And using it with the scatter density, it creates actually quite interesting looking thing that almost looks like an organism that's covered by or a structure that is covered by some sort of organism. Yeah, and when you do the relaxation, it becomes even more like a packed like this. And once you did that, if you run the 3dB smooth, you will try to smooth this out even further so that you would come out with the much more this gooey, blobby thing. If you're into this kind of geometry, go ahead and use it. Right, so any questions so far?
No, all good.
Okay. I'm going to chill out a little bit with this density simulation. Okay. And I'm going to make it just very plain and basic for now. And we can make several iterations of this. So one, I have one here, right? This, let's say this is more angular, or I don't know, square-ish. We can add another subnet network that's doing. Actually, instead of doing that, I'm just going to make a copy and then change it inside here. And for this one, I'm going to use the point separation value of 1 and so that I will have a different level of a resolution at the same time from the one image. And I'm going to change the size to just have a little bit of a fun. Yeah, it's more of like a vertical thing, vertical expression of this facade. And to get rid of this articulation, I think I'm going to decrease our ISO value just a slight bit. Yep. And for this one, I don't want to export from here. I want to export from here because I want the crispy edges. Right? And I'm going to create I'm just going to call it vertical elements and copy another one and go inside, and I'm going to get something that is a little bit more chaotic. I'm going to introduce jitter scale of 1, and then I'm going to, maybe 1 is too much. Yeah, maybe 0.1. I'm going to increase the point separation by 2 so that this will be like bigger articulation. And because this is going to be a little bit bigger, I'm going to increase the ISO value so that I can have that the smaller element sit on top of this bigger element. Yeah, I think I'm happy with this. To introduce jitter is like introducing like a little bit of a noise inside to make it a little bit more fun. So it doesn't look so like greedy. Just need to find a happy spot. Yeah, 1, yeah. So now we have these variations of an element, right? So these are like elements that's more of a rectangular, but we can also make a little bit of a blobby version with the sphere. Yeah. I will have to turn off the jitter for this one because I want most basic in the beginning, and maybe I'm going to increase the ISO value just maybe not just tiny bit, and scale mesh this one with this one. That was the box. So this can have this kind of egg shape, but I don't like this egg shape. Or it could be very thin like this. Or it could be more blobby like that. I'm going to keep it like this for now. And once you turn this BDV smooth on, all these spheres are connected and making these cute holes and shapes. So now I'm happy with this result, and so I'm going to iterate another round of it. Here, what do we want to do for this? I'm going to actually turn it back onto copy points here, because when I turn this on every time, it gets really heavy. For this one, maybe I want to make it smaller. For this one, I want this to be this kind of a very articulated small pieces, but maybe this is too small. Okay. Okay, like now it has enough of a separation between two, but then still I kind of maybe I will increase the point separation by 1.5 and the isocurve jitter scheme, maybe not jitter. Yeah, with the jitter, I can introduce a little bit of the more of a organized kind of a chaos, rather than introducing a cheater, which is a very randomized chaos. And let's say I'm happy with this. And the last thing that I'm going to make is the block that I showed you. Yeah. And increase density. I want it a little bit more compact, so I'm just going to make it 50, and yeah, that looks good. And now I turn on this one. Yeah, it becomes this this blobby object. When you make your spheres a little bit smaller, this will help. I'm actually going to try that. in here, I'm going to increase the scatter density, keep increasing it. And then I will remove the jitter so that there isn't any the floating objects. Then I'm going to turn this back on. Yeah, look at this floppy object. Yeah, like it. I like it. Okay, so we created this like 6 meshes. So how do you save this? You can go to save geometry, and the preset is a BGEO, but you don't want to save it like this. What you want to do is save it as OBJ. OBJ is the fastest to save, and then the lightest among the things that you can export in the Houdini, and it's as far as I know. So this one is a square. I'm going to call it square dot OBJ, and I'm going to save it in my desktop for now. And accept. So it added the what is it? The directory of your at the saving location. So now I'm going to hit accept. Then it will say it will save it. Okay, let's see. On my desktop, square OBJ is saved. So now I'm going to open the Rhino. You don't have to use Rhino. You can do like Maya or whatever software you feel most comfortable. But I'm going to use Rhino for now, because this is probably the most familiar software for everybody. And I'm going to put this square and then import it. It could be heavy. Be prepared for having some yeah. See, now we have this tessellated object. I'm going to bring another series of the another files from the same series in the Houdini file, which is this vertical element. Save geometry. Instead of square object, I'm going to save this as vertical element obj. Okay, hit accept. And now I kind of also want to test out the horizontal one too. So I'm going to add the horizontal as well. How do you do that? You just change this change this like it. And I might want the point separation to be a little bit smaller so that it reads the geometry a little bit more accurately. And I'm going to go back to this and then save this horizontal. Yeah. And I'm going to save all of them. And then we're going to bring it all in the the Rhino, and then we're going to render it in Variant to make an environment. The smoother surface is a little bit heavier than usually the square. Rename this sphere. This I'm going to call sphere. It's still saving. Yeah, so we cover the how to write the Houdini part, and after we take a break until 10:45, just like usual. We'll we'll go to the Rhino and then use the all this geometry to create the assemblies. But before we go, I would like to try one of the images that we created yesterday. Not this one. Tessellation. Go. Right. So I have that file saved, and I'm gonna go here and then change this one to download. Select. Yes. It's going to run all the calculations that we just wrote at once from the photos that the eBay assembled yesterday. So it's going to take a little bit, but you know, you guys can go take a break, and then once you guys come back, this simulation will be finished so that we can see what happened with the other people's the images. And when we come back, we can also review what the Carlos has uploaded to the Google Drive, and then I can make a sample of the TSNE images with the Carlos images, and also if Quinn, you, like if you have the image sliced up, please upload it so that we can look at it and then use it to make the image assembly using the TSA. Okay. Yeah. So see you guys back in 15 minutes. Okay.
Okay. I just finished the uploading of my pictures, about 2,350.
Oh, great. Um,
So I
okay. Oh yeah, yeah, it's here. Nice. Where did everyone go?
Oh, can you say that again? I'm hard of hearing.
Where did everyone go?
Oh, I don't know. Do I need to like send an email to them, because I guess I just left for like getting food or something. So I don't know why. Yeah.
Yeah, I'm trying to run your script, run your images.
Oh, but Eve told me that because she's in an architecture company, so she need to like overwork or something tonight, so she can't really follow up all the way onto.
I see. Yeah, no problem. So you have friends in your in this workshop?
Oh no, I actually Eve and I actually became like social media friends after this workshop started.
I see.
Yeah, because we wanted to communicate about some like progress in this workshop.
Hmm.
So
So I'm trying to. You're seeing my screen here, right?
yeah, I can see your screen. When I want to run this personally, I failed to run this because they say the IPython does not exist.
You need to add the file, which is this Python code.
Oh, okay, I see.
The one
So
that
just add it in the folder that include the pictures, or in the outdoor file.
Yeah. You just need to add this file
Okay, I
to
see.
the
Yeah.
folder. Do you have this code written already? The one that I covered yesterday?
Yes.
Okay, just upload it there and then we'll see if it works. I'll color your bags. Colors your bags.
Yeah. Still uploading my sliced images.
Okay. Yeah, I'm gonna run. I'm about to run Quinn Yu. Is it correct pronunciation? Quinn Yu.
签约 actually.
Chun Yu. Chun Yu.
Yeah. Isn't the pronouns of the spelling in Korean not similar with Chinese? Not similar.
A little bit different. Yeah, a little bit different. Yeah.
Okay.
What was your overall the image size again? 3,000. You said 3,000.
I think 2,300, and has it to be very specific.
Yeah,
Maybe.
this is good enough. 2,300.
Yeah. Yeah.
47. I can do 47. And then resolution 128.
Oh, yeah.
Okay. Okay. While this is running, I'm going to go back to the Houdini. And then this is the, I believe, E-phase image. And as you can see, I'm using like different features here. So since your photo was much more, let's say, saturated than my image, so I had to make some adjustment here to create this kind of a adjustment. And now you can play with this on your own. Find the sweet spot, and this is in the texture import. Okay, and then you just need to turn on the remap. Okay, and then the scale you don't have to change, but then in terms of a displacement, you can change the amount of the displacement by maybe this is too much in your case, so maybe 7. Yeah, now it comes down a little bit, right? So it's a little bit more legible. And go back to this and go to pre-voxelize, and you might need a different tactic in terms of the extrude volume, because for mine it was a little bit. It was okay to use a little bit less, but then in terms of a depth, you might want a little bit more. If you want to capture all the details, you can just leave it small, so that all the things that's above this ground will be counted. And once that's there, we're now going to the square. Now, of course, this one has too much. You see, like, it's getting there. You just need to optimize this workflow for your own images. You like this kind of point cloud aesthetic, you can do this, right? let's look at some other examples. This is vertical for your case. You still see a little bit of that, the shape that you already seen, let's say over here. When you compare this one to this one, you still see it. But then maybe if you don't want this much of a detail, you only want to capture the top part, then you need to decrease your ISO value, right? Just like this. And the next one, this looks like a bamboo for some reason, but yeah, you see, you have to make a decision. It's not just like completely automated process. You're using automated automated tools to make a decision as a designer, right? And this is with the spear. This is with the spear small, and this is the blob that's a little bit heavy. Yeah, look at that. Wow. And if you do horizontal, it will become something like this. One thing that you can try to do, because your original image was very expressive in terms of like a horizontal, vertical at the same time, like this. So you can try to harvest the vertical and horizontal element from this area. You can change the ISO value and then your flooring to harvest a specific area, and then you get this part with variations, and then you overlap them in the Rhino environment so that you can create more complex geometry from just one image. Hello, Angelo. Okay, so let's check if that can hit finish, right? Cannot identify in image file. What happened? Maybe it has the image that's not supposed to be here. It couldn't successfully load your image. These are all PNG and
yeah, there are too many, but I believe they are all PNGs.
PNG is 24. Oh, dimension is a 256, not 125.
Oh, okay, okay.
That's strange. I think that there must be some sort of a image that's not supposed to be in that in the format that is.
I'm not sure because I directly drag the file that.
Let's see. I'm going to download this whole thing.
I don't think it's necessary actually.
I'm curious. I'm curious what this is gonna make. So I wanted to run this just to test. I'm going to use actually my data set to check. Yeah, this is quite link. Image 1 to 8.
Oh wait. What about if this is something wrong with the name? It is PNG, but here it is GPT.
That could be a case.
Yeah, I mean the name you input in the code for the yeah.
This doesn't matter. This is output. This is output. So this is supposed.
Oh, okay.
Um, okay, mine's working. So.
Okay.
Oh wait. Give me a second. Oh. Maybe there is just something fundamentally wrong or changed. Something that accidentally changed in the code. Okay, yeah. There must have been something that I typed in by accident in the middle of the code. Let me try it again. Queen, wrong. Yeah, I think there must be some mistake in the image making process.
Oh, okay.
Go check your image, and then I mean, this is, was I downloading it? What's your image? When you go to the detail here, you need to make sure that peak depth is a 24, not 32 or 8 or 16. It needs to be 24 for this to run. And then if you have a discrepancy between file to file, let's say some are cut out to be 128, and then some are cut out to be 256, then it creates a problem. So make sure that everything is cut out to be the same size, and then using this the 24 instead of 32. When you save the high resolution image in Photoshop, sometimes it automatically changes the bit depth to 32. So you need to make sure that this is 24. Okay.
Okay. Okay. I'll see that.
I mean, I already have your images, some of your images. So let me test out really quick one of the images. This looks interesting enough, so I'm going to maybe out these two images. Is this already PNG? Yeah, that's already PNG. Okay, I'm going to copy. Yeah, well, how many images do I need to use? I like this one too, so let's do this one. 1, 2, 3 PNG.
A problem is I simply cannot see the number of the tab in OS system.
What was that again? Can you repeat it?
Like when so when I click the detail of the image, I cannot see the amount of the tab. Like in the OS system.
Okay. That's something that I've never heard of.
I mean, if this is the problem, is caused by like the difference between OS and Windows.
Maybe it's a maybe it's a problem with using the codec that is from the Apple.
Okay.
Okay, that looks correct. Look at that. Yeah. Maybe this is too much, so I'm going to actually bump it up to 56. Oh. Okay, created 36 items. Make it overlap actually. Okay, that's more like it. So that's one. I'm going to make a new namespace, and then we'll change this to 2, and then just run it one more time. And then now it's going to cut the second image. And then it will create the tag Quen 2, which it already did, right? And then I'm going to create. I'm going to cut 3 now. And overall now you have 866 images. So I'm going to just upload it very quickly right now. Okay, I'm loading your file again. So let's try this again. But Carlos, you also uploaded new images, right?
Yeah, I think in about 10 minutes it will finish uploading.
Oh, okay, you have a lot, I guess, or your internet is very slow.
Yeah, it was super slow, but now because it's later, it's doing it faster.
I see. Nice. My computer is struggling. Hopefully this will get done. I think my Chrome is frozen, I think. I'm going to restart my Chrome. Okay, Chrome is already clicked. Okay, now it's uploading. And I'm going to check.
Or maybe uploading the entire file.
Entire folder, yeah, that's
Entire folder, yeah.
yeah. That helps, yeah. Carlos, this is your image sets. How many images overall you have?
Like 4,500, something like that. But
4,500.
4,500. Yeah.
Yes.
Originally it was 11 pictures, and after the slice it went that high. But I don't know if that's gonna be too much for the time remaining. So as much as you want to use that you think it's gonna
I'm going to
be able to
40, right? So that we're going to be a little bit safe. What's the resolution? 128?
Mine is 256.
256, okay. And the name of the folder is Carlos. And I'm gonna name this always. I may have to reconnect this. I'm actually going to terminate the connection that I currently have. And then reconnect it. Sometimes Google Colab doesn't like it when you close your Chrome window and open it again, you lose connection. What percentage is your upload done, Carlos?
Like 97%.
Okay, then 40 should be fine. Yeah.
Okay. So should I pause the upload or
No,
can
just leave it running, it's fine.
Okay.
Unless like we're super unlucky and then when our code is trying when our code is trying to make an image collection, it catches the one that you're trying to upload at the moment, we wouldn't have a problem.
Okay, yeah. Probably won't happen, I guess.
But if we see the problem persistently, we might have to pause the upload. Okay. I'm going to come back to the eFace. Sorry, I'm multitasking today, going back and forth between everyone's file, and so please bear with me if it's confusing. I'm just going to save this in my computer for now to test this out. And then we're going to do the just very simple visualization. I was planning to do a little bit to do something more fancy, but I don't think that the time will allow for that. I wanted to like animate some of the things that's on the on the point separation. I showed you guys how like this it appears and disappears and changes, and then when you're doing the scatter, you can do it. Different types of like appearing and disappearing kind of effect. You can actually animate that in the Houdini using Redshift, but that's a little bit more involved. So we should probably I'm just gonna do a simple V-Ray still image as a result of this workshop. I'm going to close this. Actually, I'm going to save this first and then share this with you. all of you. Yeah, it's having problem loading your image, Carlos. So if you are still uploading, why don't you pause it?
Okay. Yeah, I will pass it.
You pause it?
Yeah, I clicked to pause it, but it's okay. Yeah, it's paused.
Okay. When you make these images, when you make these images, did you make sure that everything is 24-bit depth, and then it looks like it. I don't know why I'm having problem with other people's data set. Yesterday it worked like just fine. I'm a little bit confused why it's the case. Yeah, like a very interesting data sets. Very very different types of stuff, and so it would create interesting results. Oh, Carlos calling. Yeah, I wonder what's the case. Why this is not working.
It's the naming. Sorry, I got kicked out of the Zoom.
Oh no, I don't think that is naming. Naming actually doesn't really matter.
What was the issue then? I missed it. Sorry.
That's what I'm trying to figure out. Like it looks like your image is in the correct manner, 256, and then it's in PNG, and then it's a 24-bit depth. Everything looks fine.
Maybe I can upload the original images, like 3 maybe.
Yeah, you could.
I don't know.
Or
Okay, let me do that.
you can try to run it on your own Google Drive. Maybe it's a permission issue. That's when you upload it here. I mean, I have the permission there. That cannot be it. I was using eFace, the photo last time as a shortcut, and I didn't have any problem. Right, eFace, no, actually downloaded. Maybe this is the shortcut issue. Okay, let's try Queen's, because I think it's finished uploading. Actually, well, I can't do 40 for this one. Well, Carlos, I'm downloading your data set right now, so I can do some validation, and then I'll see
Thank
if uploading it to my the TSNE directly will resolve the issue. Okay, Quinn, your stuff is working, so I think it must be some sort of weird issue that have created by the either the Mac stuff, or you cut the image in incorrect way when you're cutting it. So it's working. It tells me it just generated the okay, there you go. Look at that, amazing. Quinn,
Oh, yes, it looked amazing.
Looks great.
Yeah, looks pretty cool. This is gonna take a little bit of time. Yeah, just can you send me the your original image so I can do the same thing as I did for Quinn, so that
Yeah. So in a new file or in the same file?
you can just send it through the Zoom chat if it's not too many. Just don't send the entire thing because we wouldn't have time to do the entire thing. Just select, let's say, your favorite 10 photos, and I'm going to do the 10 photos.
Okay, yeah, it's 11 photos. So
11.
But I'm not on, like I'm using an iPad for the Zoom.
Okay.
So can I just email them maybe?
Yeah, you can email it. Yeah.
Okay.
Yeah, I like this. This makes me want to do more. While Carlos is sending me that image, I'm going to include more images. That could be cool too.
Actually, we can use Adobe Bridge to like change.
Adobe what?
Bridge.
WebP?
Bridge. Like
Sorry.
on the railroad, the thing on the railroad, the bridge.
Bridge.
Do you know? Yeah, do you know this?
Like doing everything at once. You mean?
Yeah, they can export all the files to another format at once.
I see.
Also including to change the name or something. Yeah.
Unfortunately, I don't have a bridge installed in this computer, so I will have to do this manually. But it's not that many, so it's fine. You know.
Can we try like that one with the big green or something?
What was that?
I think it is the bottom right and the second one.
Bottom right, second one. This one?
No. The corner in the corner. Now in the corner. Yes, this one.
Of course, yeah. Oh, this is different size.
No.
You like this like a folding corner condition, I can see.
Yeah.
Is this the photos that you took personally?
Yes, because I live in downtown Chicago, so there are a lot
Yeah.
of
Good architectures. Yeah. Look at this Mies building. That's good. That's good.
I uploaded it directly to a new folder because it was gonna be sent as a Google Drive link. So
No.
I added a new folder that says Carlos Originals.
We did these three, and then we have these. So from 4 to the 16. Okay. All right. Just need to upload. It did not save in that folder. Where did it save? Create new. That's why. Okay. 1064. Okay, now we're gonna cut Carlos, your image.
By the way, when you were having problems the last time, it sent me a message that, I don't know, it was kind of stuck as well here. So, and then it just carried on uploading. So maybe that.
Maybe that's was the problem. Yeah.
Yeah.
It's very possible. Very, very possible. These are already all PNG, right?
Yeah, all PNG.
Oh, these are pretty high res. See, this is 32. That's 24. 32. 32. 32. 32. 24. So from here to here. This is also 32. 32. 32. You need to make sure even before you cut it, you need to make sure that all these files are in the 24 bit depth. I'm just going to use the tool resizement. To make sure this is Yeah, look at this. This is all now square dot image with 24 dot bit depths. So you can actually automate cropping and then formatting all the images using this tool. Actually, I didn't cover this because I didn't think that it was necessary, but then look at us, we're using it, and now we are transporting all this information to the splicing tool. And now we should be good. So it's pumping music. Everything's cut out. 5,000 images. I don't know if we need all of this. Well, I'll just upload it. Why not? Well, is this frozen? Hopefully not. Okay, it's still uploading. 31 minutes left.
Yeah, firstly, I uploaded the entire file for like 1 hour and 40 minutes.
Yeah, this is the problem with the machine learning. Is the data size such a such a big thing, and then as an individual, it's first of all, it's really hard to collect all these images all by yourself and then process it correctly, and then also not having it on a local machine is great, but then when you have to upload and then download all this process, it's actually a lot of time consuming process.
I see.
But I'm going to upload it anyway. I'm gonna tonight. I'm going to upload all this the cut images that I did for Corinne and then the Carlos to the Google Drive folder I shared for the image thing, so that you guys can have the access to it if I don't get to it. And if you have any questions, even after today, about like having some issues to run it or whatever, just email me. I can help you for the whatever you need. So don't hesitate to contact me for troubleshooting. I can help for a short time. Even if we have to, let's say, Zoom for a short amount of time, I can do it.
Thank you. Yeah, I didn't know it was at 32. I thought it was gonna do it automatically at 24. But yeah, my bad, sorry.
It's all right. Yeah, I had the same issue, exactly same issue when I started. I was like trying to figure this out for hours, and then at the end, it was actually the 32 to 24-bit issue. Most of the time, that's the issue for the people who don't have any experience with this image processing. Okay, so I think we have to probably move on soon to the the assemblage of the 3D model. So while we're waiting for that to upload, I'm going to do the Rhino process so that we save some time. Right, so we have this geometry. I'm going to also import the other geometries. That was a vertical element. This looks okay. Vertical element, and we want to overlap, make it overlap like this. And also remember, in Rhino space and then the Houdini space has a different axes, so you need to make the correction manually, unfortunately. And you have all the space geometries. We have one more, vertical element number 2. That this becomes very heavily tessellated surface. But you see that with the different density and then different formation, it creates this like a pretty insane looking facade. Now I'm going to use I'm going to create materials. I'm going to make a physical based material in the Rhino. I'm going to use a base color and the bump and normal, maybe ambient occlusion. There's a website that is very useful for making a material, which is this normal map generator. You can drop your texture, which would, if I remember correctly, it was 231 from my folder, where is it? Subfoot is selected. I mean, I already have generated these texture maps using Photoshop and these thermal map generator, so I don't have to go through this again. But then what I have as a texture here is a multiple images, and also what I have is from the same building. I have a different parts of this building. So I'm going to use all of these textures to texture map this so that it simulates the feel of this the context in the Rhino. I'm going to assign for the basic one, the one that's behind. I'm going to make this one this one with a little bit of a pixelated image here. And I'm going to use the bump map for that one, which is 31, 230. Okay, this is the bump map. And I'm going to exaggerate a little bit. And for the ambient occlusion, I'm actually going to use this threshold map that I created with the Photoshop. My computer is being very slow with so many things running all together. Okay, it's loaded, and I'm going to name this and then assign this to the most basic one. Now let's see how it looks. I might have flipped this object. Probably it's a texture map issue. I'm just going to do simple box map. Because it's such a high mesh, it's sometimes having a hard time. Here's what I'm going to actually bounding box, and then use the texture map, planar mapping. Select 3 points. So, and this is we need to check if this is mapped correctly, right? So to check this, okay, that's correct map actually. So we need to match this map to this one. So I matched the mapping of this one to this bounding box. You can recognize this air conditioner, so you know that this is correct. And then for these two other ones, I'm going to use a slightly different mapping. Different material. Not different mapping, same mapping. used this 231, but then with the pixels, but then this is already pixelated. We don't need to use the pixelated image for this one. I'm going to use just regular photo and then the load the normal map for this, bump it up. And for this one, we don't, I don't think I'm going to use the ambient occlusion map. I think I'm just going to use the default ambient occlusion and assign it here. Of course, your material, not material, but then texture mapping have to be matched. It creates this a mess. What I was trying to do for my own project before was to not create exactly the thing, but then has the feeling of that the original image, but then a little bit dismantled and reinterpretation of it based on the machine's geometry reading, right? So you will see your building in 3 different, let's say, representation. And then I'm going to actually change this opacity to and then I'm going to, maybe this needs to stay actually 100, and then this needs to go down a little bit, 50. And I'm going to make a duplicate of this, and then duplicate this, and then assign this to this one, and make this opacity even lighter, so that it almost acts as just like a kind of crystal that's going to reflect the light. I will add just a little bit of the metallicness, and then reduce the roughness to create some sort of a chandelier effect to the facade. Okay, maybe opacity 15 is too low. I'm going to bump it up to 30. Now we have this weird looking object, and I'm going to set up some very basic lighting in the V-Ray. And I'm going to find Los Angeles. Where is Los Angeles? L, where's L? It's Los Angeles. And time of the day, that's fine. And maybe we want something like a sunset. To set a few things here very quickly. Ambient occlusion. Well, I don't need volumetry, but render output. I'm not going to go crazy here, but we want to miss something. Okay. I'm going to move my angle here so I can control this. Actually, I don't like sunset. Let's change it. Oh, it looks all good. Maybe the sun is. Maybe just using the sun is going to create better image, just as an object wise. Okay, so when I open this image, original image, this is not original. This is original. If I compare these two, you still see like some reminiscence of what has what was existing, but then it's a completely new interpretation of the context in this the tessellation iteration. So you can do the very similar thing, or use that the sphere, the blobby thing to create your own interesting geometry. I mean, this workshop is definitely not for the visualization the workshop, but then if you guys want me to demonstrate a little bit more about the V-Ray, I can do, or we can go back to the TSNE stuff and make more images rather than working in trying to make things work in 3D, because this 3D thing I feel like is very aesthetic oriented, and everyone has a different taste in aesthetics. So it's up to you guys. What do you guys want?
You said I think last session that there were other options with the results from the TSNE that you could blend them and things like that. So I don't know if you could show a little bit of those other possibilities.
Okay.
That would be really cool.
Yeah.
I don't know if everybody else also wants that.
So more TSNE, everyone? I mean, it's nothing like too crazy. It's just a very, very simple thing. I kind of want to also see, because all these like images are finished uploading for Quinn. So let me quickly run this. I think we can do like 50 or even more, 55, let's say. Yeah. And maybe we can use the Quinn's data set to demonstrate the different different tactics for how to assemble the images. That's wrong. It has a problem with the loading images. I think they're over here. No, you should be fine. I don't know why is it not? This also sometimes happened when your internet was kind of failing. So some of your files like only uploaded halfway. It's very possible because I'm doing Zoom recording and many other things at the same time. But Quinn, I'm going to give this data set to you. You should definitely try it. I think this is going to put out really interesting image. And once you've done it, let me know how it goes. Okay.
Okay.
So I'm going to.
Also can have the access to that Python file, included in the TSNE, because I think we only have access to the image submission folder.
Okay. Yeah, I'm going to give this to you.
Okay, thank you.
Okay, you just need to put this into the collab TSNE folder, the one that I put it in the chat. Okay, everybody who doesn't have this the Python code, just put it in there. But I would highly recommend watching my the tutorial from yesterday to write your own code. It just really makes a difference. Okay.
Would you also share like how you learned to establish this workflow?
Yeah, I mean I went to SciArc for architecture technology program for the postgrad, and then the reason why I came to LA was because of the SciArc, and then I actually never liked LA, and when I arrived to LA, I saw I liked walking around the city when I arrived, and also I had a bicycle at the time, so I was just like circling around all this area, and I was super fascinated by all these like different areas in LA that represents very different aesthetic, that's very different ethnicity, very different kind of a feel of a community. And then at the same time, I was learning a lot of image processing, coding, or like cyclogen, stylegen, a lot of this GAN stuff. That's basically you're working with this huge data set, and then you are to learn how to manage this and the impact of the data set. And I was thinking maybe I can build my own data set instead of relying on some data on the online, because I don't know if you guys are interested in the theory, but Bruno Latour wrote this essay about the matter of the fact and the matter of a concern. And then this kind of applies to the contemporary society, where everything doesn't need to be truth, you know. Since after the Trump got elected, and then the main reason why he got elected as the president was the populism. And then I was super let's say disturbed by it, and then wanted to really check the field condition, check the site with my own hand, and then with my own experience, and then wanted to really transfer that experience into the machine learning process. And at the time, I didn't know that I was going to use the TSNE. I was mainly just looking for some tool to organize my data set into this something. And then I saw the TSNE as a statistical tool someone was using for this kind of linguistic purposes. And then I used to read a lot of books about the philosophy, and I was super interested in the signifier, and then the signified, and this kind of linguistic relationship between the image to the meaning. And then that's why I thought that, oh, TSNE, this is it. I want to really make the relationship between the one image to another image, playing with the signifier and the signified. And I really want to demonstrate the LA as a whole, not as a just like segmented each like suburb. I was thinking LA as this like a whole conglomerate, has a very much of a each characteristics, but then at the same time as a whole thing you make a composition. LA is a much more of a what is it? Painting that's in the form of a fragmentation, but then overall it somehow works. It's like contemporary the art. So that's why I was super drawn by it. And then I at the same time I had a capability of doing capability of making this happen while I was at the SIARC. So this became my thesis, part of my thesis, and then I developed the Houdini stuff and then all this stuff on my own as a practice to really make it happen. Yeah. But mostly it's a lot of inspirations from the city itself, and then the education from the SIARC, and then also inspiration from the colleague at the time that I was going to school with, and then also the philosophers and the architecture educators at the SIARC really encouraged me to push this way, and then also gave me a tool to really make this happen.
Very cool.
Thank you. Yeah, so let's get to the TSNE. So most of the changes you're gonna make it in the save TSNE grid here, because if you recall from yesterday, build model is just building a model. Loading an image is just loading an image. So this, you never have to touch it. And then activation is just making this image usable for AI. And not really AI, but more of a machine learning agent. So generate a TSNE is making all these data points in this like a vector space. And then the TSNE grid is where you're organizing all this file into this two-dimensional grid representation, right? And when you look at this NPD stack, this is NumPD stack. Here, let me show. So here, NB, MP array 1, 2, 3, MP array 2, 3, 4, right? This is acting as a array 1, 2, 3, 2, 3, 4. And when you look at this, it's making a matrix, right? Matrix that's taking one number here, 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 one number here. So you're making 1, 2, 2, 3, 3, 4, right? So it's basically cross product of one array to another array. So if that's the case, what are the values that you can use for? Where is my code? Yeah. What are some of the things that you can have inside? You hear what it's telling it to do is that you're multiplying NumPy mesh grid that's set up to have. So if I'm writing this again a little bit, mesh grid, and then here you have a value A, value B, right? This is value A, this is value B, and then you're multiplying it basically, and then making a two-dimensional grid. And what you're adding here is a reshape. Reshape means when you look at reshape, let's read the the description first. Give a new shape to an array without changing its data. So in the mesh grid, we have set up a certain grid setup, set up by certain grid, and we're reshaping to -1, 2, instead of having 0, 1. What does that mean? If we have to look at the lin space first to really understand it. Lin space is a return even space number over a specified interval. So return non-evenly spaced samples calculated over the intervals. Here, this, and then you see that this is start point and this is a stop point, right? But is there even number between 0 and 1? There's no even number between 0 and 1. What's the even number between the -1 to 2? 2, right? So what we're doing here is that we're basically determining spacing between the image to image. Right now, we're setting up this to be exactly right here. It's like a shoulder to shoulder, but then we can make it overlap like this, or like this. Right, so you can change this values. Of course, you have to make a number that makes sense. What would be a good number? Zero. Let's try 0. Okay. Cannot fit this number of image into this number of grid. So that means I have too big of a size. Cannot reshape array of a size 200 into shape 02. So 02 is not the number, not the right number. Could it be? Cannot shape. It didn't say the text. Let me open this again. instead of like, let's change the approach a little bit here. Instead of changing this, we can maybe change this to 0.5. We're trying to be some little bit creative without interrupting the mathematical oh, there you go, it worked. Mathematical equation fucked up. We're just trying to generate something that's going to still work in the system that we created. So when you look at this, we literally just made the grid size half, and in here in the line space, in the lin space, right? So that your overall original grid condition got shrink, so that whenever you're trying to align one to another one, your code is thinking that your image is smaller than what it actually is, so it will try to overlap to one another. You can do like even like 25, so that it will overlap even more. So let's see how it's going to get updated in real time. Remember this image, and because I didn't change the name of the file, it will create something a little different. You see now, like this got so much more overlapped, so that it creates this weird the pixelization of the from the same facade system. So it creates some sort of like a homunculus or like a Frankenstein of the facade assembly, which could be interesting to work with. I really want to use, Quinn, your data set, but then I mean, I just don't want to use my data set anymore because I've seen too many times and I get kind of sick of it. Maybe I'll use Yifei's data set.
Yeah, I'll try to go with that.
I uploaded a little bit more.
You did?
Yeah. In the folder. Pattern 2.
Oh,
Yeah.
I see.
Okay, but it seems some of them has the watermark.
That's fine. Yeah, watermark. As long as you don't have a 30-second bit depth, you're good.
What is that?
No, I mean, we've been having some issues with the image image format. So, oh, come on, please let me work. How many files?
It should be 180.
180, and then you had originally how many?
How many? Oh, this one, 330.
330. 330 plus 180. So that's 420, right? Yeah. If we can do 20 grid.
Let me double check. Yeah, it's 180 plus 336.
Or put it. Hold it. 180 should be quick. It's not that many. No.
This is 128. So do they have to be the same?
Yes.
Oh.
Then
Oh.
I'll stop this, cancel this. Yeah, cancel. I'm going to delete this.
I can upload to 56, just less images for the second.
These images are 256, right?
Yeah.
I hope that it didn't mess up the existing data set. But anyway, you had 330, right, before? 300.
336.
So 18. And let me run this. Okay, so like it now has all this like a cloud all packed together. I think actually, 0.25 is way too much. Maybe 75. I mean, to a 0.75 will create maybe more interesting result. So you see, like this is always actually back and forth. It's really more of a collaboration than the fully automated process. You have to keep trying to communicate with machine, and sometimes they get what you're trying to do, sometimes they don't. So you have to really try hard to translate your thoughts into the computer language, and also sometimes it matters what kind of data set you have, and it depends on what kind of data set you have. Your approach for the designing the process completely differs from one to another. I think it's still generating that image. See this right. Change the name of it just to see the difference. Okay. See, yeah, look at that.
Wow.
Pretty interesting results, right? It's now like a little bit more compact, but then it's making your pattern more overlap, so it looks almost like it's like a continuing, but then not really. I think that's quite interesting. Yeah, effects. I really want to run Carlos, so I'm going to upload only the partial data set of Carlos stuff, so that it doesn't take million years. And then
Yeah, it's too big.
So maybe this is okay. Let's be strategic, and then the we only need 400 to do 20 by 20 grid. 20 by 20 is quite substantial, so
For your thesis project, how large was your data set, more or less, that you remember?
I think it was like 50,000 or something.
Wow. Huge.
I can't exactly remember because for some data sets I only use for the facades. Some other data sets I use it for style again stuff, so that it has all the streetscape and then the urban scape and all this stuff. So I can't really tell. Come on, work.
What was it that you were going to show us in Blender? Was it the same that
It's
you
the same,
ended up?
and Blender works better in a larger scale. You notice that what I did in the Rhino is only like one small element, right?
Yeah.
Houdini, like you can do it with the large scale, but then my computer is not the most strongest the computer that you can find. So I've been having some problem with doing the large scale tessellation. For instance, my image for the TSNE, this is like 219 megabyte because it has all these like a big big sizes. My overall assembly size was a 19,000 pixel by 19,000 pixels, so it was having a lot of issues. So that's why I had to come up with the method to do the to do it in the Blender. Blender has its own issue and its own merit. So if you know how to do this, Blender will be so much more easier actually, because what you're doing is process-wise it's the same. It's just a different software. You're putting an image into a Blender, and then you're doing a height map. Height map is basically this same as a displacement. So once you generate that height map, you're using this tool called tissue, add-on called a tissue, so that you can tessellate the surface with more control. So pretty much similar.
So I wanted to confirm this is just one very singular element of the entire picture. So it's like the 3D architecture you showed us is like consisting of many of these, right?
Yeah. For that, yes. Yeah. Because if you're trying to do the whole image at once, you wouldn't be able to catch all these details, because every different images has a different contrast, different color values. So your the displacement tool wouldn't work that well, right?
Okay, so so it's like you made all of this one by one on each image and you combine them together.
Yes, yeah.
Oh, okay.
Basically, yes, yeah. You see, like, imagine trying to do the height map here, in this region. This and then this is a completely different color scheme. So what it will do is that the computer will think that this is so much deeper than this one, right? So that none of the details that's here is going to be caught if you're running it with this one,
Oh, okay. I see.
right?
I see.
Yeah. And for instance, like this, like a Postmas, the storefront is very colorful, and then there's like other things are so much like a darker, so it will only register like this one. So it's a just intrinsic the limitations of the tool itself, the displacement map.
So the TSN generated picture and the three-dimensional thing are actually two separate systems developed from the images.
So this was more of a compositional tool, right? You see a unique
Yeah,
shape
yeah.
in here, and then you can harvest these like unique compositional aesthetics, and then cut out certain shape from here, or harvest certain shape from here. For instance, like this itself could be a quite interesting facade layout with the
Yeah,
old
yeah.
perspective. So for that, I think TSNA is a really powerful tool. It sees the pattern that the human being normally don't see, and then making a relationship, very interesting relationship between all these elements. Like for instance, like why is this here? Like, or
And this shapes like inspired something like something of a creation in the three-dimensional shaping.
yeah, and there are multiple other ways to use the this image. Like for instance, you can easily make this each individual voxel as a point cloud, and then the input the point cloud in this like a code in a certain code, and then a code will try to find the location of that point cloud in this like TSN using this TSN any image. If I go back to my lecture, like you can do color matching, you can do feature matching, like there are different ways to do it. And then these things that you see here, these are the point clouds. And once you have a point cloud, it's very easy to make three-dimensional objects. So what I was trying to do here was that basically simplify the composition by reducing the number of elements here, but then still maintaining certain aesthetical qualities. For instance, when you look at it, like this is kind of a pattern that you see here, and then this still maintains that sort of a profile, still gives a certain feel of LA, downtown LA, but then it's a unique shape that's found by the machine, right? So that was the my desire to chase after.
Yeah, I can tell that. Yes. Yes.
Let me show you just a little bit more stuff. Where's my you see, like I made all these like the point clouds, and then but this is very early study how I'm going to tessellate the surface and then create this kind of discrepancy within the existing facade system. So it still gives you the familiar feel, but then like finding kind of new aesthetic qualities within, and from just one image, I can create this kind of a facade layout.
Yeah.
And maybe it's not this one, but yeah. But anyway, yeah. I think Carlos, the data set is finished uploading, so I'm going to run that. Very excited, Carlos?
Yeah, let's see how it looks.
Yeah. Finally. I think it's that. Just making sure. Carlos _2. Not going to overlap because this is our first run. So, and the images are image was 255, right?
Yeah, 56. Yeah.
Yeah, 256, not 55. It's promising. Still, okay, finished. Oh, it still did the overlap thing. I didn't save it. Yeah, but yeah, look at this. Look at this structure.
Looks really off.
Thank you, Yufei. Yeah.
Okay, I'm gonna.
Yeah. Good night. Bye. Let's run with the regular one. I saved it again with no overlap. Oh, I didn't change the name. Okay, that's fine. Oh, look at that. Look at this jungle.
Oh.
What is this? Is this like some sort of like a concrete structure? What is it?
Yeah, it's a garden in Mexico, and it has many pavilions made out of concrete. So
Cool.
that's yeah.
Yeah. Now you can build your own when you go to the park next time. With it. It wouldn't structurally work, but yeah, cool. Yeah, but I'll share. Let me see if I shared the Houdini. Did I share my Houdini file? No.
No.
I'll share my Houdini file.
I wanted to ask a last question about the tessellation.
Yeah.
For example, these are all precisely contextual images, but what if you wanted, like in the symbols example, to use like standalone objects, for example, columns or any other like more standalone element?
Yeah.
How could you try to tessellate those using this workflow in a way that it tries to produce that type of object?
To do that, I think it would be wise to use a depth analysis. This is like a very prevalent technology in the object detection. You know, like Tesla, the Tesla car understand how far these objects from this car, so it's self-drive, right? This is I mean, you would think that why is he talking about the autonomous cars? Like it's completely unrelated, but it's actually very much related, because when the Tesla car is driving itself, it's capturing images and understanding the depth between the car to the object, and then that's actually using the depth analysis. And depth analysis is quite similar as the displacement, because it's kind of the opposite. Displacement was developed to simulate the depths, and then the depth analysis was to understand how human understand the depths in the two-dimensional, let's say, representation. We tend to think that what we see as is actually like a 3D environment, but then it's still an image, right? It's an image that's processed by brain, and then from within this two-dimensional image, we still very much sense the three-dimensional the field. So for the depth analysis, what they were using as a preconditioning for the tessellation is that they are using pretty much like Photoshop. Like when you have let's say this kind of image, right? Then what you want to do is that you want to make all these columns into very high contrast black, or very high contrast like white, and then background to be black. So you want that column to be like very much of a pop out, and then you understood what I was doing in the Houdini. When you have like this kind of tessellated surface, I was capping it out like this, right? So that I can only harvest this much, and then throwing out this area. You can do the same thing. Let's say you have an image of a column. Column like this, and then if you do the Photoshop, this will become a very prominent figure in the foreground-background relationship, right? Oh, this is a object, this is a background. So you basically want to increase the depth of this area by a lot in the Photoshop. This is going to be like a pure black, and that this is going to be very bright white, like a marble white. Then the one thing good about the marble is also that it casts like a shadow to catch all this like striations, right? Then you can tessellate this surface with the exactly same Houdini script that we're using. You just need to cap it in the right spot, right? In the case of a column, if I draw the section, it would be something like this, right? And once you harvest that value, you just need to mirror it after, so that it becomes a complete column.
Yeah, I see, I understand. And if it's more irregular, then that's more complicated, right?
Yeah.
You need like more views, perhaps.
Yeah. For doing that, capturing this kind of a thing, you definitely can't do it with the tessellation method. You just need to do it with the photogrammetry. That's much faster and better way to do it. Tessellation is always create something alternative, not the factual object.
Yeah, I see. Thank you.
Yeah. Okay. Thank you, everyone who participate this late. taking an interest to take my workshop instead of other people, other 100 people on the list. I hope you guys learned, and I hope that I was helpful for whatever you were interested in, the machine learning or coding or the general design field. And if you have any further question, I can always answer it through email. And let's keep in touch. This world is so small, especially in the architecture field. It's very small. You never know when you will meet me or someone you saw online, in one of the students in this workshop. So yeah.
Yeah.
Thank you so much, Sanghyun.
Thank you.
It was great.
Thank you.
Thank you for sharing everything.
Yeah, no problem. Well, maybe I'll see you next year in another digital future workshop.
Yeah, let's see.
Okay.
It was amazing. Thank
Yeah.
you so much.
Thank you. Have a good night, and yeah, see you next time.
I'm sorry, I have one last. Maybe the other people can feel free to go, but I have one last.
Yeah,
Maybe it'll be them question. Yeah. So it is about the coding we made yesterday.
Mhm.
About let me share my screen. So it is this, and I ignore the first one. So I'm not sure where I should insert the file name or the file size or something in this.
What kind of what?
Like yeah, just like something like this,
Ah.
yeah.
I see. I see. So let me share my screen back. I think I know exactly what to do.
Okay.
So here, the step that I did was, let's say, what you have it on your screen is this, right? You have all this information, and then you have
Yes.
on the top. But what you actually need to do is that delete all of this and just leave this, right? And this expression mark Python tsne grid.py, it's calling a file that is in this folder, which is a tsne grid.py, the file that I shared with you just today on the chat.
Yeah. So you mean we should like export the coding we manually made to a file and put it in the folder?
Yeah.
Oh, I see.
Yeah.
Okay.
Yeah. We were just
like
using,
in what way? Like we can directly export it from the collab, or we need to copy paste it to some other coding application or something.
no, you can just use even like a notepad. You can even use notepad and then have this and then save it as a not txt to O file, and then the tsne grid py.
Oh, okay. I understand. Oh, okay. Yeah.
Ideally, you want to use something like a PyCharm. PyCharm is the coding environment that you can write things on it.
Okay. Yeah.
Community edition is free, so you don't have to pay for it. I don't want to create this new environment, but let me open. let me show you what I mean. So you can open this like a tsnegrid.py file with the PyCharm Community Edition.
Yeah.
And this actually has the same or similar environment as the Google Colab has. Google Colab, it will automatically just highlight all these things, right? So it's actually easier to write it here, and then make all of this as a text file, but not with the .txt, but then with the py extension.
Yeah. I see.
Yes.
Yeah. Okay. Thank you so much. I think all the problems got resolved now.
Great. Yeah.
Yeah.
Great. Good to hear. Yeah.
Okay. Have a good summer.
Yeah. You too.
It's really nice to have this workshop because I am exposed to something I never had a chance to know before, and for such interesting, really meant to know like digital sculpture thing. Yeah.
Yeah. That's why I'm here for, right? So yeah, I'm glad that you enjoyed it and learned something.
Okay. Bye bye.
Bye, everyone.
Bye, thank you.
Thank you.